Hi, I'm Guang, I'm 50 years old. In this lesson on the techniques and applications of definite integration, we are taking a look at two different integration problems. So take a look at the first integration question that you have here, which is a double limit. X squared plus y squared is smaller or equals to 2x. X squared y dx dy. So first of all, you might want to take a look at what kind of boundary you will see for this question. Right. So x squared plus y squared is smaller or equals to 2x. How about you move the 2x to the other side first? So x squared minus 2x and then plus y squared. And then we can add 1 on both sides. So then you have x minus 1 squared plus y squared is smaller or equals to 1. So this, you should be more familiar with it as it is one of your circle equations. So what will this circle look like? So essentially this is a circle of radius 1 centered at 1, 0. So centered at 1, 0 with a radius of 1, alright? So that is the kind of circle you will be seeing, alright? So what's so special about this circle over here? Now take a look at what kind of integration we have. So whether it starts from x or y, whether you want to do it with polar coordinates or Cartesian coordinates, it doesn't really matter. So if you want to change it into polar coordinates, well, you have x will be r cosine theta, while y is r sine theta. So for this question, what you can change that into is, so let's say you want to change it into polar coordinates, which will see r cubed cosine square theta sine theta r d theta. Then your range for r will be from 0 to, so for your semicircle, let's say you know this diameter of the circle. So if you want any point, you can link your point to the two ends of the circle of the diameter, which then you have a right angle triangle since it is one of the properties of the circles. So once you have that right angle, you should be able to use your trigonometry to find them. And since your diameter is 2, so that will be 2 cosine theta. Next, what will you be seeing? Which is your theta. So theta is from negative half pi to half pi. Alright, so this is the integration that we will have to solve. Alright, so r to the power of 4, which means you have 1 over 5, and then r to the power of 5 inside. Then you have to substitute in r is equal to 0 and r is equal to 2 cosine theta d theta. And next, you're just going to sub in your values for r. So 2 to the power of 5 is just 32. So outside you have 32 over 5. Then you have integrate from negative half pi to half pi. Alright. And then you're going to have sine theta, cosine to the power of 7 theta d theta. And next, you're just going to put the sine inside your d theta, which you'll get negative 32 over 5, integrate from negative half pi to half pi, cosine to the power of 7 theta, d cosine theta. And then when you integrate this, you have negative 4 over 5, cosine to the power of 8 theta. Then substitute the values, negative half pi and half pi. So when sub in either of these values, you just get 0. So final answer for this question is a 0. Alright? So it might seem pretty weird that when you integrate over this kind of an area, you get 0. But that's, you have to look at what kind of a boundary, or should I say integrand, you have. So important things are the boundaries and its integrand. So the answer for the first example is 0. How about let's take a look at what the second example will give us. But of course, the processes for this example will be, you look at what kind of graph you have, which is a circle with radius of 1 centered at 1, 0. And then you can just change everything into polar coordinates. Then you just determine what kind of integration you'll be facing. Alright, so moving on to the second question. So, in your second example, you'll have double integration across the boundary of D. And D is bounded by y is equal to 1 minus x squared and y is equal to x squared minus 3. Or your integrand is x times y minus 1 dx dy. Right, so y is equal to 1 minus x squared and y is equal to x squared minus 3. Let's take a look at what kind of graph that would show. So most of you will probably be familiar with the y is equal to x squared graph. Y is equal to x squared minus 3 is just going to be your y is equal to x squared graph, but it is moved down by 3 units. Right, so this is y is equal to x squared minus 3. Of course, you can also go and mark out your different coordinates if you want. You have a negative square root 3, square root 3, and negative 3. Okay, so that's if you want it. And then next, y is equal to 1 minus x squared. So that will just be it inverted and moved up by 1 unit. Alright. Okay, so what would this area bounded be? That would just be this area over here. Right, so this is your y is equal to 1 minus x squared graph. But of course, you would have to need to know what kind of intersection points you have. So x squared minus 3 is equal to 1 minus x squared. You have 2x squared is equal to 4, which gives x is equal to positive negative square root 2. So you're going to have negative square root 2 substituted in to get y is equal to negative 1 and square root 2 negative 1. Alright, so those are your 2 points of intersections between these two graphs. So now basically you need to know what order are you differentiating from, whether first with respect to y or first with respect to x. Of course, it seems simpler to first integrate with respect to y first, since if you integrate with respect to y first, that would just be one single integration. Or if you want to integrate with respect to x first, you have to be aware you have to separate them into 2 different integrations, since they will have 2 different kinds of boundaries. One using your y is equal to 1 minus x squared graph, the other is using y is equal to x squared minus 3 graph. Right, so how about let's take a look at what happens if you integrate with respect to y first. So, integrating with respect to y first. Now, x, y minus 1, dy, dx. Of course, when you're integrating with respect to y first, x would actually be taken as a constant. So you can choose to move the x into one of the more outer integrations, alright? So the range for y, it goes from the bottom function to the top function. The bottom function is x squared minus 3, or the top function is 1 minus x squared. Now the range for x is what we just found, negative square root 2 to square root 2. And then you're going to see, so you can just integrate it first. So integrate from negative square root 2 to square root 2, you're going to have x, then half y squared minus y. Then you substitute in the values x squared minus 3 to 1 minus x squared. And then dx. Alright, so next is just to substitute in the different values you will be seeing. So x multiplied by half 1 minus x squared minus half x squared minus 3 squared minus 1 minus x squared. Then you have to add x squared minus 3. Then dx. Right, so this will be whatever you see. So of course we would want to simplify it as much as possible before we integrate it. So let's take a look at how we can simplify it, alright? So from the first term, you're going to have half. So half minus x squared plus half x to the power of 4. Or for the second one, you're going to have minus half x to the power of 4. Then you have to add on 3x squared and then subtract 9 over 2. So realize the terms of x to the power of 4 would actually cancel out, or you just add the others. So you're going to have 2x squared minus 4. And next for the next two terms, which is plus 2x squared and then minus 4. Alright, so this is what you're going to have. So you realize the first two terms and the second two terms are, or should I say the last two terms are basically the same, which then you can just have 2 integrate from negative square root 2 to square root 2. Then you multiply the x inside, which you'll get 2x cubed minus 4x. Then dx. Of course, if you want, you can also take out another 2. Well, now we can integrate it. So 4, 1 over 4 x to the power of 4 minus x squared. Then you substitute in the values negative square root 2 and square root 2. And of course, when you try to substitute in the values, you'll realize, well, you're just going to have, so square root 2 to the power of 4 is just 4. And then when you put this in, it's also a 4, so just 4 minus 4. And then you'll have to subtract. So 8. And then since minus a negative, which you'll get plus 8, which is your final answer is actually just another 0. Now, both of these questions, you solve them in different ways. The first example, you used polar coordinates to solve them. The second example, you used Cartesian coordinates to solve them. And they seem like they're very different questions, although their kind of thought process is pretty much similar. You determine its boundaries, integrate it. But how come both of them are equal to 0? So there comes a problem. Do you notice any similarities between the two functions? If so, what are the similarities? Of course, the most obvious similarity you probably see is the boundaries are all symmetrical. This one is from negative square root 2 to square root 2. Or the previous one you have negative half pi to half pi. So what if their boundaries are symmetrical? Then you have to take a look at what kind of integrand you have. Now within this integrand, let's say in this case you have 2x cubed minus 4x. So this here is an odd function. So when you have an odd function and your boundaries are symmetrical, both sides, they'll actually cancel out. So like you have a left side, let's say to the left of the y-axis or to the right of the y-axis. So the two sides would actually cancel out since it's an odd function. But of course, in other kinds of questions, you might want to avoid that or whatever. But for these two examples, they're actually pretty similar in a sense that they have an integrand of an odd function while having symmetrical boundaries, which in that case, if you can recognize it, then that is pretty much immediately a 0. Since an odd function, you just have positive on one side, a negative on the other side, or negative on one side and positive on the other side. You can always find the same as long as it's pretty symmetrical, alright? So that is what's so special about these two examples over here. Although being different, they're actually both equal to 0. Right, so I hope for this lesson you're clear of these two examples so far. and that you have learned why can these integrations be equal to 0, which of course you have to be aware of integrand and boundary. So those are 2 things you have to check for, alright? So I will be ending this lesson here. I hope you enjoyed it, and thank you for your watching.